Angles of elevation and depression. An angle of elevation is an angle measured from the horizontal plane upward from an observer's eye to a given point above the plane. So we're going to start off looking out of someone's eye and drawing this horizontal line that goes straight out. When we elevate that line upwards, the angle created here, this is going to be our angle of elevation. So we always start with the horizontal line, we go upward, and then this is the angle of elevation that we have. When we talk about an angle of depression, it's an angle measured from the horizontal plane downward from an observer's eye to a given point below the plane. So again, we're going to start out with that horizontal line again, and this time we're going to depress that line downwards, and then this is the angle of depression that is created here. So again, it's really important that in both the angle of elevation and the angle of depression that you start out with that horizontal line, the line of sight, and then you're either going to elevate upwards or depress downwards. And as you make that motion, the angle created by moving the horizontal line is the angle that we are working with. Here we have two different diagrams, and our task is to identify each of the following as an angle of elevation or an angle of depression. So I'll walk through this first diagram with you. Angle 1, we have this man, we have the horizontal line out, and to get the other side of the angle, we had to depress downward. So angle 1 is an angle of depression. When we look at angle 2, here, from the observer's eye, we go out horizontal, and to get the other side of angle 2, we needed to elevate. So this is an angle of elevation. Next, for angle 3, from the same observer's eye, we go out horizontal, but to get the other side of angle 3, we depress downwards. So angle 3 is an angle of depression. And lastly, for angle 4, out of the observer's eye, we go horizontal, and to get the other side of angle 4, we elevate. So angle 4 is an angle of elevation. Now I want you to go ahead and pause, try to identify angle 5, 6, and 7, and check back with me when you're finished. Hopefully you found that angle 5 was an angle of depression. Angle 6 was an angle of elevation, angle 7 was an angle of depression, and angle 8 was an angle of elevation. So remember, it's really important that you always start out with that horizontal line of sight first, then you either elevate or depress. Let's go ahead and try this word problem. Person is standing 40 feet from a flagpole and can see the top of the pole at a 35-degree angle of elevation. Let's go ahead and start with that. We see a person, and then they are standing on the ground, and we have a flagpole. It says the person is standing 40 feet from the flagpole, so make sure you label that carefully. 40 feet. The person from the flagpole. And it says that they can see the top of the pole at a 35-degree angle of elevation. So be really careful. Angle of elevation. The person is going to be looking at the top of the flagpole, but the angle of elevation always starts out horizontal. So from that horizontal view, we go upwards to get that angle of elevation to the top of the flagpole, and this is going to be our 35-degree angle. Then it tells us that the person's eye level is 4 feet from the ground. So this point to this point, this is 4 feet vertically. And then it asks for the height of the entire flagpole to the nearest foot. So we're looking for the height of the entire flagpole, we'll call that X, to the nearest foot. Now, in all of these problems, we are going to be using our trigonometry to help us. So let me go ahead and write out our SOHCAHTOA. Now, in this diagram, we have to be aware of what our right angle is. So here's our right angle in that triangle, that horizontal line straight across, and of course we are assuming the flagpole is straight upright, so here's the triangle we're working with. Now we are going to be looking for the entire height of the flagpole, but that flagpole just has a portion of the height in this triangle that we're looking for. So I'm going to go ahead and call this portion of the triangle that we're looking for Y. So in this triangle, let me bring it out and kind of isolate that piece. We have, here's our 35-degree angle. This distance is going to be 40 because that's how far away the person is from the flagpole. Here's our right angle, and this height right here is Y. So when we've isolated the triangle, here's the angle, here is our opposite side, this is our hypotenuse, and so 40 is our adjacent side. So when we're trying to find the right trig function, we're using opposite and adjacent. So opposite and adjacent is going to be our tangent. So we're going to set up the tangent of angle 35 degrees is equal to the opposite over the adjacent. Now we're going to go ahead and solve this for y. So in order to solve for y, we need to multiply both sides by 40, and then this will cancel out. So we have 40 times the tangent of 35 is equal to y. And then when you put this into your calculator, you should get 28.0 when it's rounded equals y. So this y right here is going to be 28.0. In order to get the entire height of the flagpole, that's going to be y plus the height of the person. This gives us the height of the flagpole that we're looking for. So we just need to take that y value, 28, and add 4. So we're going to get 32 feet is the height of the flagpole. Now let's try another problem. This one says that an eagle perched 40 feet up in a tree looks down at a 52-degree angle of depression and spots a turtle. So let's go ahead and start with that part of our diagram. Now you don't have to be an artist. Here's my tree, here's my eagle, here's the ground, and here's my turtle. So we need to find our right triangle. Here we have the eagle to the turtle, his distance to the ground, how tall the tree is, and how far the tree is from the turtle. This is going to be our right angle. Now it says the eagle is perched 40 feet up in the tree. So this height right here, this is going to be our 40 feet. And it says that the eagle looks down at a 52-degree angle of depression and spots the turtle. Now you have to be really careful here. When you've drawn this diagram, you're going to be really tempted to make this 52 degrees, but you have to remember that an angle of depression and an angle of elevation always starts out horizontal. So from the eagle, we need to go out horizontal, and then the angle depresses downward. So this is the 52-degree angle. Now, you have a couple options here because the triangle that we drew doesn't have that angle measure in here. And what we're looking for is how far the turtle is from the eagle. So the turtle is here, the eagle is here. This is the direct distance between them. So what we can actually do is if we drop this all the way down with a right angle, we can either use this triangle over here, and all we have to do is relay that this height of 40 matches this height of 40. Or what you could do is if you know that we've created this rectangle, this 52 degrees, you can subtract it from 90 in order to get this angle measure of 38 degrees. So I'm going to focus on this triangle right here. And I'm going to go ahead and look at my trig functions, my SOHCAHTOA. And let's go ahead and label what we have. From the angle of 52 degrees, 40 is the opposite side, and then x is the hypotenuse. So in this triangle I've highlighted, the opposite and hypotenuse uses sine, so I'll set up sine of the angle 52 degrees is equal to the opposite side over the hypotenuse. Now, in order to solve for x, we need to multiply both sides by x, the denominator, so this cancels out. Then we have x times the sine of 52 is equal to 40. Now x isn't isolated yet, so we need to divide both sides by the sine of 52 so that this side cancels out and we're left with x equals 50.8. So this is going to be the distance from the eagle to the turtle, rounded to the nearest tenth of a foot. So we would say 50.8 feet. And then that's our final answer. So you do have options when it comes to the angle of depression, but it's really important that you remember you have to go horizontal first, then depress downwards. Now, if you had worked with this blue triangle and used the angle measure of 38 degrees, you would use a different trig function, not sine, and then you would end up with the same answer. Now I want you to go ahead and pause, try this problem, and then check back with me when you're finished. Okay, hopefully you got that your final answer was 104 feet. So to walk you through it really quickly, here's your tree, here's you, and then you should draw your triangle with your angle of elevation at 61 degrees. And then remember, your eyes are a distance of 4.5 feet from the ground, and you are 55 feet from the tree. The task is asking you to find how tall the entire tree is, but you only need part of the tree's height for your triangle. So when we pull that triangle out, I assigned a variable y for that part of the tree's height. So that's going to be the opposite and adjacent side, which leads us to tangent. So the tangent of 61 equals y over 55. Multiply both sides by 55 to isolate the variable. And then when you put this into the calculator, you'll get 99.2. Now, when we go back to answering the question, x is the entire height of the tree, y is just the top portion. So we take x is equal to y, that portion from the triangle, plus the height our eyes are from the ground, because that's going to be the same over here as it is over here for the rest of the tree's height. So when we add that together, we get 103.7, but the directions did say to round to the nearest foot, so the whole number. So 103.7 will round up to 104. Hopefully you got that answer. If not, check over your work again with mine and see where you made your mistake. Otherwise, I'll see you in class for more practice.